Hello, and thank you for joining. The topic of today's presentation is strengthening the security of your software supply chain. Hi, my name is Mark Townsend. I've been in the industry for 27 years. I currently lead the professional services organization for Invicti. I've been working with customers to secure their organizations. I'm a co-author of several patents and industry standards with the Trusted Computing Group. Our agenda for this webinar will start with a bit of background information on software vulnerabilities discovered in the supply chain. We'll also share real-life stories on taming web vulnerabilities and examples of success. We'll also discuss the supply chain security best practices as we see them today. And we'll also cover some of the frequently asked questions that come up on the topic. By the end of the webinar, you'll have a better understanding of how to strengthen the software security of your supply chain with effective application security tools and processes in place. But before we dive into the presentation, I'd like to quickly introduce who we are. Invicti has been a global leader in web application security since 2005, with its headquarters based in Austin, Texas, and branches located in Malta, Turkey, and the Czech Republic. The company was established as a result of the merger of two prominent cybersecurity firms, NetSparker and Akinetics, which brought together their extensive expertise in web application security. With a dedicated workforce of over 300 professionals, Invicti has earned a reputation as a reliable partner in the cybersecurity industry, having secured over 800,000 applications and serving more than 3,600 customers worldwide. Invicti's testing technologies, including dynamic application security testing, interactive application security testing, and software composition analysis, are all fully automated throughout the SDLC. Everyday products and services from cell phones to automobiles are increasing in sophistication. As a result, supply chains often rely on 4 or more tiers of suppliers to deliver finished goods. The supply chain can include proprietary code binaries, open source libraries, third-party custom-built code, and white-label products. Each of these external parties can expose organizations to new risks based on their ability to properly manage their own vulnerabilities. Let's quickly look at the cybersecurity landscape. The number of cyber attacks is increasing, costing organizations more every year. The stats are gruesome. Gartner predicts that by 2025, 45% of organizations will see some sort of impact from a supply chain attack. According to the latest Verizon Data Breach Investigations report, 40% of all data breaches stem from attacks on web applications. 96% of web applications have at least one vulnerability, which only takes one to get breached. In a comprehensive 2022 study of current and historical data notes, a 44% rise in publicly reported cybersecurity incidents over the past decade, with a typical cost of more than $250,000 per incident, grows to $52 million for the top 5% of incidents. It therefore comes as no surprise that in response, organizations must protect themselves with a defense-in-depth approach and have a robust framework that reaches back into their software development practices to ensure that the applications they build are inherently more secure. And to many, even a few years ago, the risk of software supply chain attacks was limited. Prior to SolarWinds, the awareness was low. The SolarWinds incident helped increase the cybersecurity awareness and scrutiny, but not much more. A year later, the topic returned with a vengeance in the form of Log4Shell and subsequent vulnerabilities in the ubiquitous Log4j library. It was the Log4j crisis followed by the Spring4Shell vulnerability that really got the ball rolling in terms of legislation and formalized cybersecurity guidance. To carry out a supply chain attack, attackers often target the weakest links in the supply chain. Usually these are small vendors or open source communities that lack robust cybersecurity postures. Target, for example, infamously suffered an attack that cost $61 million, which began when their air conditioning supplier was compromised. While it may seem insignificant, even a single security incident with a small third-party supplier can wreak havoc on the greater supply chain. By compromising just one party, attackers can set off a domino effect to destabilize the greater supply chain. However, we are 1 year since Log4Shell and 2 since SolarWinds. We don't know what's coming, but what we do know is we have to start somewhere. SBOMs are a great start. Everybody starts with SBOMs, but I encourage that we don't end with SBOMs. Government organizations and commercial organizations alike are starting to adopt an approach that started with an executive order with the US government to create internal policies about applying software security to the supply chain. An SBOM today is just a statement of compliance to many CISOs. It doesn't help us understand what the true risks are. The reason is SBOMs are just a statement of what the components are involved in a particular piece of software. They don't tell the entire story. It's not about the software components used, the open source libraries that are used, but it's how those are connected by the developer that is using them. SBOMs cannot describe the connections or the code placed around those libraries. And this is where DAST or dynamic testing can help. And a great example of this is when Spring4Shell hit the market. We had customers that approached us to load and analyze a lot of their applications for the Log4j for the Spring4Shell vulnerability. And we scanned 70,000 apps for one customer alone across the course of a weekend, looking for the Spring4Shell vulnerability. Software supply chain attacks are made possible by companies leaving security until the end of the development process. Preventing software supply chain attacks requires shifting security left and scanning for web vulnerabilities prior to production releases. With the supply chain, this shift left approach is shifting towards evaluating that software before it is loaded into your network. We recently worked with a global logistics company that was adding more and more applications into our platform. And one of the challenges that they had was working with their vendors that supply them with software. Before any application is put into production, whether it's developed internally or developed by a third party, the application security team will conduct a full dynamic application security test in addition to SBOM reviews. And they shared a story with us how one of their vendors ended up buying our software because our software was finding continually some high and critical vulnerabilities with their application. So our customer influenced their supply chain to adopt, a shift left strategy before sending software. And when they did see that, the overall number of vulnerabilities, decreased in production software that made it out to our particular customer. So we saw a great reduction in the number of potential threats to our customer. We're currently working with a global law firm, and they have an application intake process like many of you do that requires a risk assessment to be performed before that application is put into production. And this is mainly about the concern of securing their highly confidential client data. The challenge that they had was performing risk assessment at scale so that they're nimble and able to respond to the dynamic demands of the business. We help them control the cost by automating the process, by integrating our software as part of their existing intake process. When a request to launch a new application occurs, their intake process will automatically load the application, execute a test on that application, and then provide the results of that application. Formally, this would require a human being to process the intake form, load the application into a DAST tool, run the DAST tool, and then evaluate the results. Invicti is nimble enough to be able to integrate, with each of these clients and you to enable the automated assessment of your applications before you go into deployment, increasing the security of the supply chain. We've been helping customers secure their web apps and APIs for more than 15 years. Based on their success, we put together supply chain security best practices that I'd like to share with you today. First, train your developers on security. Developers are keen to write secure code, and enabling them will save you resources in the long run. Next, know your suppliers and who you do business with. As we've seen from case studies, conducting testing before accepting supplied code improves the overall security of your organization. Conduct risk assessments, especially after deployment. Publish and consume software bill of materials and require them of your vendors. Don't stop with the SBOM. Include systematic security testing, as mentioned earlier. Regularly scan your software for vulnerabilities with automated security testing tools, such as Dynamic Application Security Tools, DAST, Interactive Application Security Testing, IAST, and Software Composition Analysis, SCA. Test both as in the pre-development and pre-production environments, as well as test after deployment. Let's discuss what constitutes a successful AppSec program. Firstly, complete coverage provides an accurate picture of the entire threat landscape, so there are fewer surprises. Secondly, efficient scanning with integrations into CI/CD workflows and remediation means you can scale your AppSec program. Thirdly, accurate results save developers and security professionals time, reducing false negatives. And last but not least, continuously scan all of your apps and APIs, as this secures the entire attack surface and enables more effective rapid response. Built on zero trust architecture and the 4 pillars of AppSec, a mature and high-functioning security team should operate utilizing the expertise of everyone on the team and filling gaps with educational training around security best practices. Ensure that the right people have the right level of access to the right data and systems at all times. Map the entire attack surface to ensure everyone has a clear snapshot of the agency's risk posture. Deeply integrate threat protection throughout the entire software development lifecycle, as outlined in Pillar 4 of the CISA's Zero Trust Security Model. Establish and maintain a thoughtful response plan that everyone can access and follow in the event of a cyber incident. So what's so special about DAST? The bottom line is that vulnerabilities cannot be ignored at any point in the software development lifecycle. Indeed, identifying and managing all threats can be daunting, but when faced with the possibility of an attack that could derail development or worse, cause a breach for customers of deployed software, testing for vulnerabilities both early and often is an obvious solution, and it's the specified standard. Benefits of vulnerability scanning. Tools such as Invicti's AppSec solutions continuously work on all phases of the CI/CD pipeline, scanning both during development to validate the code and scanning pre-production to validate the environment, scanning test systems to validate production code, and scanning your production environments is critical. Integration with build tools is fundamentally important, so you get notified automatically with the vulnerability for that code segment and providing remediation techniques to fix the problem. A big advantage of Invicti's DAST tools is that we provide automated confirmation for the majority of important vulnerabilities to prove that they're real issues and not false positives. In other words, when a vulnerability is identified, we attempt to safely perform a test attack and retrieve a piece of data as evidence. And that is why we provide AppSec with zero noise. Let's look at some of the frequently asked questions on software supply chain security with the aim to equip you with some more practical information, particularly helpful for security practitioners. Question: are we part of the software supply chain? Many companies may not actually perceive themselves as being part of the software supply chain. However, on the consumption side of the software supply chain, if you are like most organizations, your dev teams account for 20% or less of the code in your applications. This means that the remaining 80% or more is sourced from somewhere else outside of your company. Understanding the prevalent usage of OSS is a necessary first step into gaining clarity into the underlying risk that components can pose if they're not managed appropriately. If you don't know what you have, you won't be able to secure it. Whether you're developing software, handling compliance, focusing on security testing, or part of a legal team working on an acquisition or securing intellectual IP, you're among the top stakeholders who must take part in examining and securing your use of open source code. How do we know the overall level of risk in our applications? To accurately assess the level of risk in its applications, a software supplier must be thorough in how it evaluates and takes actions on results. As mentioned earlier, the right AppSec tools can help strengthen your application security, but can't exist in a vacuum. Risk is best assessed and mitigated by having clearly defined policies in place. Not only must an organization identify the level of risk that's present, but it also define what level of risk is acceptable. This process can and should include cross-departmental involvement with participation by software creators, engineering, security, and legal teams. At some organizations that we've worked with, we have seen rules such as software must ship with no high or critical vulnerabilities, but medium vulnerabilities or low vulnerabilities may be deemed acceptable risks by the organization, especially when balanced if the urgency of the application in getting the features to market are critical. And this is important for you to test and assess as you're acquiring from vendors in the market. Are you going to accept those same findings and that same risk? Question: we already ask our suppliers if they pen test their products. Isn't that enough? Asking the right questions can provide a lot of information about a software supplier, but questions alone are not enough. Where possible, security managers need to do their own due diligence. Penetration tests are one way to do this. But the most important thing that we've seen with penetration tests is many of them are conducted annually. What happens between the penetration tests? There's a lot of software releases in there. By applying DAST into your supply chain, you can not only ensure that you are testing your application, you've looked at the penetration test, you looked at the SBOM, but you're also testing that application. I think it was in the 1980s, but trust but verify was a key theme there. Question: are there supply chain security frameworks we should follow? Yes, many organizations are turning their attention to supply chain security frameworks such as the NIST framework. In fact, for federal agencies and contractors, President Biden's executive order on improving the nation's cybersecurity makes the use of a software supply chain security framework mandatory. These frameworks are designed to help organizations understand the main pillars of software supply chain security so they can identify risks and take steps to mitigate them, as well as prepare for what to do in the event of an attack. I want to thank you for your time. I hope this information has been helpful. If you would like to find more information about Invicti, please go to www.invicti.com. Please feel free to connect with me on LinkedIn, Mark Townsend, for further information. Thank you.